Madsen, and I'm the project grant manager for PMZ Engineering, and this is a presentation on our project, which is County Road 38 reconstruction. Okay, so the project summary of this is the reconstruction of the County Road 38, and along the project limits is the design of a building. There's going to be a design of a visitor center, and also the design of an office and residential building for the client to choose from later. Both of them will be designed fully out, but only one of them will exist at a time. The redesign of the roadway and the County Road 31 and 38 and 21 intersection, the design of a stormwater management system for the project, and the design of a wastewater treatment facility for the building. So I'm also the I'm also the structural engineer for this project, and my building is the steel framed one. So the overview is that it's going to be a 2-story steel frame building. The uses will be a visitor center, which includes like event spaces, conference rooms, just a lot of area for people to come to Goshen and to gather. And the area will be around 41,000 feet square. And there will be an attached outdoor space of about 1,200 feet squared, and the roof will be accessible for maintenance. Some of the design criteria, the relevant codes and manuals, a lot of the CEE 716 was used. This is for load combinations, the minimum design loads, so that's like the dead loads, the live loads, based on occupancy and materials, and also the online hazard tool for the snow loads, the seismic loads and wind loads, which later too will come in for lateral design at a future step. The Willcraft deck solutions are determine the weight of the decks, and the AISC manual determines the properties and the weights of the steel members. The gravity loads are on the right side, and they just list some of the materials that are used in the loads that are associated with those materials. For the live load types on the floor, for the lobbies, corridors, and assembly areas are all 100% 100 PSF. So the entire floor will be designed with that, so that way the client has a little bit of freedom with how they want to position their rooms, and that way it'll all work out with the 100 PSF. So first, the roof framing plan is shown here. The beams will be spaced at 5.75 feet, and the analysis was run in RISA, and RISA gave some suggestions for the members and what size they should be. These were all checked with hand calculations, and they are in accordance with the AISC specifications. The floor framing plan is very similar. The beams are spaced a little bit farther apart. This is because the deck is a little larger or thicker, and so it allows for beams to be spaced a little bit farther apart. Again, RISA was used to determine some of the sizes, and they were checked with calculations, and they are in accordance with the steel manual. So for the future work, this will include column design, the lateral system design, the outdoor space design, and for all of this, the cost estimate as well.
So I'm Barrett Church. I'm the second structural engineer on this project. So my building is a reinforced concrete building. It's supposed to be 2 stories, multi-purpose, and it's in the shape of an L. The total area is around 35,000 square feet, where the office and academics, it's designed for office and academics on the first floor, and for residential, strictly residential on the second floor. And it was also required that the roof be accessible for maintenance purposes. So my progress to date. So first, the load determination was determined for the different sections of the building. So for the second floor, it was all designed for residential use. And for the roof, it was designed using the snow load given by the CEE 7 hazard tool. And then after that, I went on to the beam and slab design. So The minimum beam height and the minimum slab height were both designed using the ACI code, where the beam width was designed using the recommendation of 1.5 to 2.0 for the ratio of the height to the width of the box beam. I've also completed the floor plan designs, so the second floor and the roof have both been designed using RISA floor plan. And then lastly, I've selected the longitudinal steel for all of the beams. So just a little bit about the design methodology. The CEE 7-16 code provided me with the different loads for my building. And then the ACI 318 code provided me with the minimum beam height, minimum slab height, the beam dimensions, the rebar selection, and also the ACI coefficient method. And the ACI coefficient method is just a method to determine the member moments for the different beams. And then this, in turn, was used to check that RISA floor plan is actually spitting out the right values for the moments. And then once that was verified and I validated it, the member moments were then determined to be less than the design strength, which means the beams will not fail in bending, which is what we as structural engineers want. So just a couple things about the loads. The second floor was designed mostly for 40 PSF, which is for private rooms and corridors serving them. But it was only designed for the north and west wings, whereas the intersection, which is this section right here, was designed for 100 PSF. And the reason for this is just to provide more accessibility or options for the client in case they want like a meeting room for the residents or a game room for the residents, just to provide that option. If they don't want that, they can obviously just make apartments there. And then also the dead load for ceiling work and the dead load for flooring was also used in the design of the second floor, whereas the roof was designed using the snow load of 25 PSF and not the live roof load, because the snow load is greater than the live roof load, which means that the snow load will control in that case. And it was also designed for ceiling work and self-weight, of course. And then, as you can see over here, the lateral parameters, these were used just to transfer RISA floor into RISA 3D. Here's my floor plan as you saw before, but what I want to focus on here is just the beam parameters. So for the second floor and the roof, I am designing the beams all to be the same, just because it's the loads are relatively the same on both the roof and the second plan or second story. Just in this space is the major difference on the second floor because of the 100 PSF, but that still won't be much of a factor when designing the beams. And the reason for this is just to reduce the complexity of the overall design and reduce complexity of construction for my building. Here's just an isometric view of my building, just to give a broader scope and a better understanding of what I've designed so far. And then for the future work, most of my future work is just reinforcement, so the rebar lengths, the splice lengths, the rebar shear, the column rebar, and then after I complete that, I will move on to the CAD drawing, so the various section views and profile views. And then after that, I will complete the cost analysis, which will include the material, labor, and equipment costs.
So I'm Ethan Fecky. I'm the transportation engineer for PMZ Engineering, and the transportation scope involves a complete redesign of the County Road 38 and County Road 21 intersection, along with the addition of a multi-use path along County Road 38, a center turn lane that will go from the intersection all the way to before the bridge, and a parking lot design to accompany the visitor center, and a path underpass that will go under the bridge and back onto Kircher Road. So my design criteria, I mainly used the INDOT design manual and determined a design vehicle of a WV67, and the Elkhart street standards were used to determine my parking lot dimensions, and the AASHTO Green Book was used to find the horizontal curve radius, and INDOT figure 46-2D was used for the minimum curve radius, and a 45-mile-per-hour design speed was given by the client. So my intersection design includes a dedicated left and right turn lanes at each approach, and it includes 4 channelized islands that will be connected with pedestrian crosswalks. And as you can see, the multi-use path as the dotted line will come through the intersection, and then in the northeast section, and then come out the southeast section. And from my previous progress presentation, I moved it from the north side to the south side. And the radius for each right turn will be 125 feet. So my typical section of the road includes the center turn lane, which would be 10 feet, 2 12-foot travel lanes, 2 9-foot paved shoulders, and roadside ditches. That will be a 4-to-1 slope, the 24-foot clear zone, and the mainline pavement will include HMA surface, intermediate, and base, along with the cross slopes of the travel lanes being 2%, the cross slopes of the shoulders being 4%, and then the multi-use path on the right side will have a cross slope of 1.5%, and they'll be draining towards the roadside ditch. Oh, and will be made out of concrete. So the visitor center parking lot will include 110 spaces. They'll be 9 by 18 feet. And per ADA standards, there's 4 handicap accessible spots with 1 van accessible spot. And from the dimensions at the bottom, you can see there's 2 or enough space for 2 lanes of travel throughout the parking lot. And my maintenance of traffic plan will include rerouting eastbound traffic up to County Road 19, up to Indiana 119, and then back down to Indiana 15, then back on 38, while westbound will go down Indiana 15 to County Road 40, and then back up County Road 19 to get onto 38. And the only vehicles allowed through during construction phase will be residents and emergency vehicles. And for my future work, I will continue my detailed design work, incorporate the water resource design, and address the path underpass.
Thank you. As a water resource engineer, I will introduce for the next part. So the first is the water resources scope. We will improve the water quality, reduce the solid loading by 60%, and all improve surface to infiltrate or filter at least 1.25 inches of runoff. And the design system to control storm water runoff and improve water quality. So now this map shows all the designs. So for the red one is the visitor center water design, and the blue is the covered, and the purple one is the one dry pump, and the yellow line is the ditch, and the green line is the permeable pavement. Oh, by the way, the orange line is the permeable pavement shoulder. So let's see some details for the visitor center water design. So the green is the rain garden, and the purple one is a smaller dry pump. And we use the bell well, which is the orange line, just to connect to each other. So for the design criteria, all the design data are follow this. And until now, we have done the rain garden, the dry pump for road and the visitor center, the permeable pavement for parking lots, and the permeable pavement for road, and the permeable pavement for shoulders, and also for the cover. So let's see some details for the rain garden. So for the rain garden, we have 3 layers. So the soil layer, it can observe the solid and help the plants grow through their root system. The gravel layers, we use the 0.5 inches the gravel inside here, and it can slow down the runoff speed of the storm water, and filter the solid. For the vertical pipe, the diameter is 0.5 feet, and it can make sure the rain garden can keep the overflow, and the grass on the slope, it can make sure the stormwater can go inside the rain garden. So for the dry pump for the visitor centers, we still use the 0.5 feet diameter pipe, which is on the horizontal, and that can just make sure the drainage of the stormwater. And the grass on the slope, that can help the stormwater go into the dry pump. And the dry pump for the road, we just use a large size. The reason we do that just it can get the flood control. And for the permeable pavement shoulders, it is designed on the both sides of the road, and we use the porous asphalt. For the gravel layer, we still use the 0.5 inches the gravel inside the gravel layers, and that can keep the that can fuse the solid and support the structures. And for the pipe, we use the 0.5 diameter pipe to get the drainage of the stormwater. For the parking lots, we use the 5 centimeters the grass pavers, which is the top one. For the organized layers, we use the just some silt or some sand inside here that can make sure it can help the plant screws and absorb the solid. And for the next layer, we just add the gravel and the sand to make sure that can add the support. For the gravel layers and the pipe, they are similar like the permeable pavement shoulder. And for the permeable pavement for the road, we just use the porous asphalt, and all the design will similar like the permeable pavement shoulder. So for the culvert, we have 2 culvert design. So for the first one, the length is 120 feet, and the diameter is 3.5 feet, and the material will be concrete. And the tailwater velocity will be 3.81 feet per second. For the next one, the size and type will be the same, and the tailwater velocity is 3.36 feet per second. For my future work, we will complete the cost estimate and complete the CAD drawings and the ditch design and the design for overflow provisions.
My name is Emma John. I'm the environmental engineer for this project. I was tasked to treat the wastewater for the proposed visitor site or center. I need to design for 25 years of future growth and a minimum daily flow of 1 million gallons per day. The design criteria that I'm using is the Indiana Administrative Code for Water Quality Standards and the Water and Wastewater Engineering Design Principles and Practice textbook that I'm sure most of you are familiar with. My progress to date is I've designed the bar rack, the partial flume, the fine screen, the grit chamber, and the equalization basin. The first step in the process of the treatment is the bar rack. It will filter out the larger debris from the wastewater so it doesn't clog further downstream. There are 2 channels that are designed and each have a bar rack in them that can handle the complete or the total flow per day. And this is for redundancy since you don't need 2 going at the same time. There's a stop gate that will block one of the channels at all times. The bar rack design will have 5mm steel bars spaced 40 millimeters apart and will span the entire channel width and depth. The next step in the process is the partial flume. First thing I had to do was I had a minimum flow rate. I needed the peak hour flow rate. I used this graph from the Water and Wastewater Engineering textbook to find my peak hour flow rate, and that is 1,972 meters cubed per hour. I then went to the table that's also in the same textbook, and I found the smallest possible partial flume that would accommodate this flow, and using those measurements, of course, drew my partial flume. The next step is the fine screen. There will be, for redundancy's sake, 2 of these fine screens. I selected the Hubbard fine screen set screen, and they will each be in a channel, and the channel will have 10 times the width, so a length of 6.1 meters. The next step is the grit chamber. I selected to use a vortex grit chamber, the other option being an aerated grit chamber. I selected the vortex because the aerated grit chamber can have an odor and release volatile organic compounds, and since we are close to a residential area, I don't think the residents would be very thrilled with that. So I selected the vortex. I selected the Hubbard Vortex Grit Chamber Vormax, which can hold a capacity of up to 3,000 liters per second, which is more than handles what I need. The last step that I've designed so far is the equalization basin. I did not have a flow per hour, so I created using my peak, average, and minimum flow rates per day, and idealized daily wastewater flow rate, which is the graph here. Using that graph, I then put it in a chart per hour and got my volume in, volume out, and eventually my total sum, sum of storage that I needed. I used the largest sum over here, added 25%, and got a storage of 11,640 meters per cubed. For my future work, I have to design the primary settling, biological treatment, secondary treatment, the collection and discharge of the wastewater, and then finish my cost estimate and CAD drawings. Thank you for listening to our presentation. Are there any questions?
So, I have a couple questions. Well, Ethan is the first one. For your traffic routing slide,
Yeah.
the traffic coming from both directions makes a left-hand turn. Is there a reason for that? Or would it make more sense to have, like, the westbound go to the north and around, so they make they're not making,
Yeah, I see what you're saying.
because there could be some traffic coming out of there, right,
Mhm.
local, so.
Yeah. I'll be sure to fix that, thank you.
Okay. And then Andy, I had a question for the, did you design the permeable pavement for structural strength? Like, is it large enough? Is it gonna support the traffic loads? Did you consider that in your design?
Yeah, for the,
Like the others,
this one?
yeah, like 0.164 feet, is that, well, that's just the paver thickness?
Yeah, this is the paper, is the depth.
But how, yeah, okay, so I guess my original question is, like, is that permeable, or are your permeable pavement systems structurally designed?
Yeah, I think so. For this design, we use the grass paper, just that is work for the parking lot,
Mm-hmm.
and the grass paper is just can just save the money and can make sure all the systems will work well.
Okay. And you have porous asphalt though too, right?
Yeah.
Is that structurally designed? Because usually there's a water volume design and then a structural design.
Yeah, that's it. Yeah, that is water design.
Okay, so you should do a structural, somebody on your team should do a structural design. Yeah,
Sorry.
okay.
Okay, stay with you, Andy. Looking at the schematics you presented, if you go to the overall, I see the size of the rain garden to be significantly larger than the dry pond.
Yeah.
Is that to scale, or is it, you see, I'm looking at the dry pond,
Yeah.
your detention pond, and looking at the rain garden. Do you have the actual sizes, surface area, acre feet?
Yeah. So for the rain garden, the washer. Oh, sorry, can I say it?
What, can you tell me what are the sizes of the dry pond and the rain garden?
Yeah. So for the dry pond, which is near the visitor center So the size will be like here.
100 by 50.
Yeah.
And the rain garden,
And the ring garden is like here.
another 100 by 50.
Yeah.
Same, well, they are different depth. What's the depth of your dry pond?
Yeah, so the reason I have two dry pumps here because for the middle part it doesn't have some flood control, so we add the dry pump over here, which is a larger size that can make sure that all the system can have a great flood control.
Do you have an outlet structure on the dry pond?
Uh, for this one.
To release the water? Just a pipe, like a 6-inch pipe?
Yeah.
And why do you call it a dry pond if the pipe is sort of like maybe 1.5 feet above the bottom of the pond?
Yeah, well, I got some information. It told me that like the 0.5 feet diameter pipe, that is the normal size, and it can work for the floor.
I talked to Professor Weiss afterwards. Lynn, you showed W sections. Now, I'm just trying to understand your design. Are these like steel joists going between the girders? Yeah, or are they all W sections at that distance of, in this case, like 7.67 feet? So do you have steel joists going between the beams?
No, the beams are going the beams are the vertical direction, and then they're in between the girders. And there's no joists.
And you think that your roof, that Rollcraft will be supported by that space? Did you
Yes.
look at what is the typical width of a Rollcraft panel?
Yes, there's the manual states what the maximum spans are there, so with the deck that was selected,
I think they were bucket.
okay.
And
I'll
that's
double check on those.
too large of a space for like a panel to sit over like 7 or 8 feet or something like that. Okay.
Okay, I'll double check on that.
And Ethan, I mean, based on the schematic you presented, the cross-section of the road, I just quickly added the numbers, they add up to 86 feet. So what is the existing right-of-way for this road?
The existing right of way is, I don't think I counted or measured it in CAD, but the existing is just 2 lanes with ditches, so we probably have to purchase some right of way along the
Do you
road.
know how much land you wanna buy?
Not yet, no. It will probably be a decent amount though.
I'm going quick in there. Emma, one simple question. When you presented the screens, I saw a 16 million gallons per day compared to the 1 million gallons. So if you go to your like screens, yeah, go back, this one. So up to 16 million gallons per day. Why do you want to select a fine screen that is so large, all what you have is a 1 million gallon per day?
Honestly, so I can definitely look into it again. I was having trouble finding spine screens that gave me like a flow rate and like online. So I can look for more, but I just was having trouble finding something.
Okay. And for your bar racks channel, what design flow did you use?
Oh, it's been a while since I looked at the bar rack.
You
I
state-
believe I used the peak hour flow rate, so what you see here.
Okay, that would be good. actually, if you did that, but I did not hear it, so you mentioned the peak flow rate for the partial flume, but thank you.
I had this is a county road, right?
Yeah.
Okay, I guess you looked at the standards. Is 9 feet shoulder, is that standard? I mean, you're not gonna get much of a truck on the side of that without causing,
Yeah, so I used
Traffic.
the 42-T in that design manual for that. I probably should have looked at the Elkhart street standards to see if they had any shoulder requirements, but
I would be willing to bet that NDOT is bigger than Elkhart is, but you might wanna check that
Okay,
9-foot
I will.
shoulder. I haven't seen 9-foot shoulders for a long time.
will do, thank you.
And then you'll need to work with Andy as to
Mhm.
who's gonna actually design the thickness of that permeable pavement.
Yeah.
So just 2 questions. One is about the dry pond for Andy. So what type of requirements are on a dry pond for draining? Like, is there a certain amount of time? And did you take that into consideration? Not.
For which one?
Like for the dry pond, so if it fills up with water,
Yeah.
can the
Yeah.
water stay for days or do you?
I've seen that can just stay for some weeks, and we're just over that the water will just go inside the pipe and just through the dish and go inside to the.
So it'll all drain out eventually through the pipe or that? I'm not sure. So what's the difference between a dry pond and then just like a detention basin?
Well, I think that just the dry pond just make sure the flood control and the detentional basin just also work for that as they are the same.
Okay. I don't know. Great. For the other thing, for the pedestrians crossing,
Yeah.
so you have it at the intersection, which is fine. Looking at like where, like how do you think people are going to use, I guess, the pedestrian path, like where are people going to come from, where they're heading?
So,
Like in general.
Okay.
And then maybe, if you explain a little bit about why you placed it at the intersection versus maybe other options.
okay, yeah, so the scope provided had us have a multi-use path along the north side of County Road 21, and I explored just having it wrap around the northeast side of the intersection. However, that would increase our pavement or just like the width of use probably by another 10 feet. We'd be going into like driveways and houses, and so I decided to move it to the south side. And for like the people who use it, we're probably planning to connect it to maybe the visitor center, so people could, if they're like on the north side of County Road 38, they could ride the path all the way along and then go up to the visitor center if they wanted to.
Okay, so stay on that one a minute. Are you done? Yeah. Okay. Where is the visitor center on this map right there?
Yeah, I kind of cut it out, but you can see the little.
Oh, okay.
right there.
That's fine. It's fine.
My bad.
That's the front door.
And where is the entrance to the visitor center for vehicles?
So,
And did you look at the separation of that entrance to the intersection, distance-wise?
yeah, so I don't have it shown, I'm sorry, but I have about, I'd say there's probably about 20 to 30 feet of space between the entrance and the road.
No, I mean from the intersection to the entrance. You don't want conflicts of people
Yeah,
turning in
so,
when they're trying to drive through, and do you have a right turn lane to get into the parking lot, or what are the geometrics there is kind of what I'm asking.
yeah, so I
didn't see
haven't got that far in the parking lot design yet, but that's something I'm gonna address is having right turn lanes and giving enough space, so it doesn't conflict with movements going through like movements going through this right turn lane, but I will make sure that's adequate.
Okay.
Okay, thank you.